So in this video, I'm just going to quickly go through an overview of Git, since we're going to be using Git, GitHub Classrooms for our class this semester. It's not necessarily important to know all the details of Git, but it will be useful to sort of have an understanding about how Git works and a little bit about how it's different from GitHub. So in case you don't know, Git is a distributed version control system. It stores files, mainly code, keeps track of changes made by multiple people or just a single person, possibly on multiple machines. Allows for metadata. We call these commit messages on each change to identify them, and enables us to merge sort of divergent sets of code that multiple people have been working on. So this is why it's used a lot in industry, because multiple people can be working on a document and they can be easily merged together to create one version of that code. GitHub, on the other hand, is a website that stores Git repositories, so repos is what we call them. It's centralized storage, allows user control, allows classrooms, which we'll be utilizing this semester, and it adds a nice web interface to Git, but it is not Git, right? It's separate. It utilizes Git, but it's basically just a website that stores it. So the relevant Git commands that you'll hear in the other videos in this series that will be useful to know are clone. So basically, clone makes a copy of a Git repository, whether it's off of GitHub or off of another machine, but it basically makes a working copy of all of the files in that repository on the machine that you're actually working on. So it takes it from the server, puts it on your local machine. Add. What add does is makes additional files available for tracking. So by default, not every file is tracked. Not every file in a folder is tracked, which is good because you don't necessarily want class files, right, to be uploaded since they were compiled for a specific machine, but you want the Java code to be compiled. So you have to manually tell it which files need to be included in the repository. A commit is basically a stop point. So it's a point that you can look at. It's a history way sign, basically. It's something you can go back to. And it's also, a commit is where we store the metadata, right? So it tells you what exactly was done in that particular set of changes. And then push basically takes your local copy of all of the changes that you've made and pushes them. So it takes all of the commits on your local machine and pushes them to the host. So that might seem a little intimidating, but we're going to go through a little example of this, and I'm hoping that helps to explain it a little bit. So here we have GitHub over on the left here, and we have our local machine over on the right, and GitHub has a repository in it, and it has these two files, file 1 and 2. But we don't have anything in our folder on our local machine, right? There's nothing there yet. There's nothing there until we clone it. So we clone my repository into my folder, and you can see now that in my folder I have an exact copy of both files, file 1 and 2. And we can make changes to those files all we want to, and as we make those changes, it doesn't change what's up on GitHub. And every time so I recommend doing this every time you get up from your machine or even switch away from a window. What we're going to do is we're going to set a marker, right, which we call a commit. So we're going to it takes a snapshot basically of all of the code that we have, and it saves it somewhere. And we can add a label, like say we want to say made edit 1, right? Obviously that's sort of non-informative since we know that it's edit 1 here. But you can see that at this point in time, all we had done was make edit 1, and maybe edit 1 is added a new print statement for us to be able to test something. Notice that after we make this commit, right? After we make commit 1, again, nothing has changed over on GitHub, right? These changes are still only local. And we can make as many commits locally as we want to. Right here we make another edit to that file, and we made another commit. And now we have a commit that takes a snapshot of just the one edit, and we have a commit that has a snapshot of a second edit. In order for those to be viewable on GitHub, right, we have to do what's called a push. So what we do when we push something is it pushes all of our commits over, and then it updates all of the files that are currently there to be the most recent commit, right? Basically, the snapshot of the most recent commit is the set of files that are in the repository. One thing that can happen if you're not careful, though, is maybe we make a third file, but we didn't add it to our repository. It's just in the same folder, right? We didn't specifically say it. So when we make another commit, this snapshot doesn't have file 3 in it, even though now it's in that folder. So we don't want to do that. What we want to do is when we make a new file, we want to make the new file, and then we use a command called git add, or in some IDEs, this will be, we're saying it's now tracked, right? Or it's sort of in the same way in some IDs, they call it staged. So a staged change or a staged file. Right? It hasn't been committed yet. It's not in our commit, but it's in our working repository. So then when we make the next commit and we push it, now file 3 is up on GitHub. Right? So remember, the commands that we really need, oops, I went too far. Clone makes a copy on our local machine. Commit makes a save point that we can come back to. And push takes all of our changes from our save points and puts them up on GitHub. And add puts new files, right? It stages changes that haven't been committed yet, right? But that we want to add to the next commit. So for the actual logistics about using GitHub Classrooms for assignments, there's separate videos for each of the development environments that we might be using. So I would recommend you watch those videos real quickly. And we will discuss this more in lab the first couple weeks, but this will be useful as a reference to come back to later in the semester.